Students, this is the flag help video for Unit 7, problems 1 through 30. Taking a look here at number 3, it says, find the length of the segment indicated around your answer to the nearest tenth if necessary. So we start with what you have here. First off, X only goes from there to there. That's it. And then we have a radius, which is 14.7 from the center to the edge. We have our piece of our chord, which is 13.5. And because there's a right angle there, if perpendicular, then bisect. So we know this over here is also 13.5. Really important. When you don't know what to do, you look for a right triangle or you make a right triangle. So we're going to see if we can swing that radius around somewhere. So we're looking to see if we can't swing that radius around somewhere in order to create a right triangle, which, looky there, if you swing it right around there, you get a right triangle. Let's pull that right triangle out so you can see it. We have this part right there, which we have in light green. I'm going to call that Y. Your ultimate goal is to find X. And then we have this 13.5 here, going this way. And then, of course, we have the 14.7 radius come around here. So you can see here that you can easily solve for the light green here, which is Y, using Pythagorean theorem. Leg squared plus leg squared equals hypo squared. Now what that's going to get you is right there. Now that's not your X, but that will help you find X. You're going to have to finish the problem on your own. But before we move on, I'd like you to put your pencil right here in the middle. And I'd like you to trace a radius there. Remember, radius goes from center to edge. Now there's one more place I'd like you to trace a radius. Ready? From the center. Trace very slowly. Yes, that's a radius 2. That's going to come into play to solving for X. Okay, it says find the length of the arc. And length of arc, let's write that out. We're going to write arc length. And that is simply a fraction of the circumference. Fraction of circumference. And remember, fraction is the theta over 360 times d pi. So our arc length here, our theta, trace it, is 225 over 360. It would be your whole thing. Times your diameter. Now, it's really important. Do not just look at this and pick up the 11. Physically trace your diameter. Physically trace it all the way across. Behold, that's not 11. That's 22. And then pi. Clean that up. Leave it in pi form. And don't forget your units. It's length, so it's 1d. (13 and 14) says find the measure of the arc or angle indicated. Now, as you do this, it is super important that you keep this part of your reference booklet right in front of you so that you have the different kinds of angles, what they look like, and what the relationship is between them and their arcs. You must have this memorized. So have this handy where you can see it. So let's take a look here. Remember, we only want to find ultimately what's being asked for, which in this case is that angle. But my rule says, don't just look for what they tell you to look for everything. So we're going to start with what we know to be true. We know from here to here is 60. And we know from here to here is 120. Let's see what else we know is true. We have 80-degree angle here. It is an inscribed angle. It's an on. So the on angles are the ones you frame. So your Post-its, if you have them, go right there, one on one side, one on the other. You frame it, and we learned this, that this angle is half of this arc. So we write it like this, that the angle is the arc over 2. Our angle is 80 this time. We're looking for our arc over 2. So basically, we can see our arc is going to equal 2 times 180, which is 160. So this way out here is 160. We ask ourselves what else we can find. Just kind of keep working along. If that blue is 160 and that's 60, then this here is going to be 100. Now let's see if there's anything else we can find. We're going to sweep this around. Ready? We're going to go 60 plus 100 plus 120. We get 280. I want to find that last one. Remove those Post-its. So we're going to go 360 minus 280. And of course, we get 80 here. Now remember, we're trying to get that red, so let's frame it up because it's also an on, so your Post-its go right there. And we see that this angle grabs this arc. If you look carefully, you can see what that arc measures and how to get it. This says, find the angle indicated assuming that the lines are pure. So that word tangent is really important. That's the trick to this whole problem. We have a tangent point right there. We have a radius that meets it. Tangent and radius in the same sentence. The word tangent and the word radius in the same sentence. I wonder what that reminds you of. Might remind you of if tangent to a radius, radius if tangent to a radius, right angle at the edge. That means there's a right angle right there, friends. Why? Because there's a tangent and a radius. So there's a right angle there. There's your tangent, and then there's your radius. Now we're ultimately looking for this angle right here, but rather than focus on that angle, why don't you focus on what you know is true? A couple things. First off, we know all radii are equal, so that's equal, that's equal, that's equal. You might want to ask yourself what kind of triangle you have going on here. And you might want to ask yourself, what else could you do maybe with this triangle? Use those two pieces of information, knowing that you have a right angle there, to solve for the unknown. Just find the measure of the arc or angle indicated, which lines of are tangent. So for these problems, you are paying attention to this page. And it's important for you to identify what kind of angle you have going on here. and then pick up the appropriate equation. So this angle right here, that is a tangent. And trace it, that's a secant. And we look here at tan secant or secant tangent is arc minus arc over 2. So we write it like this. Angle equals big arc minus little arc over 2. Now, circle plug chug. Angle equals, so we have your circle angle. Look, oh, looky there, we actually have the angle, so we're going to go 60. Big arc minus little arc, which we don't know. We'll call that x over 2. Pop that over 1. Let's multiply and solve. So notice what I did. I traced, I identified what kind of angle it was, I wrote the equation, then I circle plug chugged. Said find the measure or arc or angle indicated. So you start by tracing, figuring out what kind of angle you got going on here. So I trace, and I see that that is an on angle. And I look here, and we see, oh, lo and behold, it is inscribed. An angle equals half the arc. So I write that down. Angle equals whatever that arc is, we're going to sweep it over 2. Now we're going to circle plug chug very slowly. Angle. I'm going to write it down here. 4x plus 20 equals the arc 10x plus 14, and it's over 2. Pop that over 1. Solve for x. Now don't get all happy when you solve for x. X is not your final answer. This is not algebra class. We want to ultimately find the arc KL, which is here. But in order to find KL, we obviously need that value of x. So x is an intermediate answer, not the final answer. Says here, use the information provided to write an equation of a circle. We start by writing our generic equation of a circle, which you need to have memorized. It's x minus h, parentheses squared, y minus k, parentheses squared, equals radius squared. H and k are the center of the circle. Now we look at what we've been given here. We have the center of the circle. There's our H. Draw an arrow, come right here. We're going to pop in our H right there. And we have our K. We're going to pop it in right there. Then we take a look. Whoops, we don't exactly have a radius. Let's see what we do have. We do have circumference equals 14 pi. And let's see what else we can do with that. We know circumference is C. D pi, I C D pi. You can see now our diameter is 14. You're going to use that to find your radius and then clean it up a little bit. Okay, this one, it says we want to find an equation of a circle. So again, we're going to start by writing out the equation of a circle. X minus h, parentheses squared, y minus k, parentheses squared. Let me keep my color straight here, equals radius squared. So once again, we need our h and our k, which is the center of the circle, and we need our radius in order to write the equation. Problem is, we haven't been given either one. So let's look at what we have been given. We've been given a circle with diameter end. Let's draw that. There's the center of my circle. So there's my h and k that I want, that I don't have at the moment. And here is the length of my radius, which I still don't have at the moment. But I do have some endpoints for diameter. So I'm going to do this. One endpoint is 1,9. The other endpoint is going to be 13,9. So I asked myself, from those endpoints, how can I get both my HK and my radius? Well, we know our HK is our center. And to find that center, we're going to use the midpoint equation because the center of the circle is the midpoint. So we add the x's, divide by 2, add the y's, divide by 2. Add the x's, divide by 2. Add the y's, divide by 2. You're going to use that to get your h and your k. Now, once you have that, then we're going to find the length of the radius, which, of course, is a distance concept. So you're going to find the distance between the center to one of these endpoints. It doesn't matter. Just write your distance template. You're going to find that. Leave your answer in simplified radical form. That's going to find you your radius. Once you have these items, the h, the k, and your radius, then you can plug them up here, clean up your equation, and you're done.